All right, so I'm going to cover a couple of the larger or bigger questions of feedback, so that way if you guys want to redo the assignment or fix anything because of the delay, you'll have the opportunity to do so. Again, I apologize for the delay. Coordinating different time zones can be a bit of a headache sometimes, so please forgive us. Okay, so first thing I want to start off with is the primary question about station points. So just to reiterate what a station point is a station point is you, right? And it gets abbreviated SP. Essentially, it's where are you standing? And if it's not where you're standing, it's where are you setting up your little camera on a tripod to take a picture of something that you would see, right? And so what the camera sees or what you see in terms of what's in frame, we typically call that your picture frame. Right, so pretty straightforward meaning. Now, the picture frame doesn't encompass everything in terms of it doesn't encompass the, potentially doesn't encompass the horizon line. It may not encompass the vanishing points either. It's really what you see. It's that framing. Now, for what we're doing with our homework, we're not really worried about the picture frame. But this just kind of contextualizes things a little bit. What we're more worried about with our perspective drawing is our horizon line. So again, our station point is where are we standing and we're looking out from. And in terms of what we're dealing with, we're more interested in the horizon line, right, than anything else. Now, from a side view, you can almost, if we want to recontextualize this a little bit, we can think about it from the side as this is where you're standing. So this effectively becomes your station point, and you are looking out at something, right? And obviously the world is round. So if you're standing as the world curves up, right, where your sight line hits the end, or where that ground plane kind of goes up and meets where you see that intersection point, that becomes your horizon line in terms of, again, think about it as what bisects your vision. So that's the station point. That's really what it means. Now, relative to everything else that we do, what's really important about station point? Well, the short answer is nothing. The station point is kind of pointless, right? As far as generally drawing goes, it's not really that important. It does become important, though, when we're trying to calculate things, and that's why we're bringing it in specifically just to learn how to plot perfect cubes, right? This was the previous week's homework. We needed the station point to really calculate how to plot cubes. For everything else, we don't really need to know where the station point is or anything like that. We assume typically that a station point, is kind of off page. Now, as far as plotting a cube goes, we know that what we need to establish, I'm just going to do this separately over here. What we need to establish when we're plotting a cube is two lines that come out from the station point that are 9 degrees to each other, right? And we'll just use this currently as an example, right? And we'll use this as our little point for station point, right? This little dot here. And we're going to have two lines that are going to come out, and where they intersect gives us our vanishing points. VP over here, VP over there. So this then, again, this is more about the context of things, and why we talk about station points is really just to contextualize things a little bit more. But what's happening here is, what we're assuming is that whenever we're dealing with a perspective drawing, we have a station point and we have two lines that come out to form our vanishing points. And what we're assuming is that the lines that are coming out happen to be at 9 degrees. And because they come out and they form our vanishing points, that means that any time I draw lines coming out or going back to the vanishing point and they intersect to create a corner, that corner is also 9 degrees because it matches this, right? So of course, stands to reason if I change that, then this is going to change as well, in relation to whatever this becomes as well. But by default, we generally have this position that, hey, it's at 9 degrees, therefore everything in here is also going to be at 9 degrees, right? So that's kind of how it works. Now let's kind of get rid of this so it's a little bit cleaner, so we can move forward to the next part of the explanation. So, as I mentioned before, and why I brought up picture plane is, what can happen is this situation where we include the station point is, as we start drawing, let's say for example, I'm going to draw a box down here. This isn't going to be a cube or anything, it's just a straight up sort of block. So as I start to draw this block over here, all right, let's kind of remove the rest of this so that's a little easier to see as an example. Right. As we're looking at this, it kind of looks okay, right? And that's because we're kind of sticking roughly in the middle. But if I start to draw this object, let's say a little bit out over here, some of my object is going to look, well, parts of my object, parts of the block that I'm drawing is going to start to look a little bit odd in the way that it's going to start looking a little bit distorted. And the reason why it's starting to look a little bit distorted is the same reason why when we're doing our normal perspective drawings, the same thing happens. And that's because we're starting to draw outside of our cone of vision, right? And cone of vision is typically measured from your station point. So if I move up here vertically, right, it's going to hit a point over here. That's going to be where my cone of vision is going to start extending from. Now, there's a very particular way of calculating what your cone of vision is. General rule of thumb that I find quite useful as a rough estimate is it's going to be about a third of the, if you divide the distance with your VPs into thirds, it's roughly going to be about a third, right? So it's going to be divided, if I divide this roughly in thirds, it's going to be something like this. So that means that within this, if we imagine a circle, right, this cone of vision, anything in here is going to be relatively well positioned. Anything outside is going to start to look a little bit distorted. Now this guy here kind of avoids it though, and that's primarily just because it's sitting, smack bang kind of more or less in the middle here. But as we start to deviate out from that cone of vision, things start to shift a little bit. Now cone of vision, mind you, doesn't have to be in the dead center. It could be placed over here, right? In so much as, let's say our horizon line is here, in so much as our station point could be here. Well, let's not do it that extreme. Let's say here. And we could have, right, our lines coming up to form our VPs running at something like this. And so this goes up, continue through here until it intersects somewhere there. And that's going to mean that my cone of vision is actually going to start there, right? Whatever third it's going to be sit somewhere in here. Right. So cone of vision doesn't necessarily have to be dead bang in between your vanishing points. It's really predicated off where your station point is, right? Because it's your cone of vision, right? What you see. And as a result, it's going to be based off where you're standing, which is what that station point is. So hopefully this gives you a little bit more context in terms of what is the station point for, right? How do we use it and all that sort of stuff. And to kind of shorten this a little bit more, a station point is where you're standing, right? Where are you looking at this image from? What is it useful in terms of how is it useful? Well, it's primarily, I'd say, most useful when you're trying to do these more precise calculations of I need a perfect cube or whatnot. But in general, in terms of your everyday practice, you can assume where that station point is and not have it on page. It really doesn't matter. So long as you have your two vanishing points, right, and a horizon line and you know where they are, the station point is not that critical because you can always reverse engineer ultimately where you want that station point to be by pulling lines out where they meet, at 9 degrees to each other. So the station point in that sense of our everyday workflow is not particularly necessary or important, I should say. But for more specific calculations, yes, then it becomes much more important, and we do need to know where it is to be able to establish things in sequence. Now, specific to the question of do we use station points for that super reflection assignment, the answer is no. You don't have to. You can if you want to, but you're not. You don't really need to. And to kind of kill two birds with one stone, let's kind of dive into that, as well as looking to placement of the rooms and how to mirror certain letters. And we're going to run through this from start to finish, right? So of course, what I'm going to do is actually, let's assume this is your page, right? So that way we're kind of working with what everybody has. Really important rule. Use rulers, right? Don't try and do this freehand. None of this is meant to be freehand. Every single line you're trying to draw for this assignment, use a ruler to do it, right? Use a ruler and use pen so that you're not getting any kind of artifacts either. And I really do stress that you can switch to digital if you want, but I assure you it will be faster, easier, and you'll learn a lot more if you do this traditionally. Digital has this, there's a lot of things you can do digitally, and there's a lot of benefits that you get from working digitally as well. But if you're trying to learn something, digital is probably the worst thing that you could do for yourself. Digital offers, the benefit of digital is it offers a lot of flexibility. It offers a lot of options. The downside of digital is that because of all those things, it makes learning significantly harder. Right? I know there's a tendency to go, well, isn't it a better technology? Isn't it a better thing? Is what professionals are using, etc. And it's all true, right? But you have to understand that when professionals are doing these things, they started learning traditionally, right? So you're looking at a very advanced tool. But enough about that. Let's actually dive into this element here that we're trying to answer. So as I mentioned in our previous class, I would typically place the horizon line quite high up, and that's because we're looking down on the objects, right, to be able to get the most out of those reflections. And I'm also going to place my horizon lines on page as well. Now, for the sake of this, in the context of this feedback that I'm recording now, since we just talked about station points, let's actually put that in then. Let's actually utilize station points. Now, as I said, we typically don't, in terms of we don't need to, but just in this case, let's kind of use it. So I'm just going to move this a little further up so that we make the most out of the width of it. So let's say this is my station point. This is what I have, and as a result, I have my vanishing point here and here, right? These are my two vanishing points. I'm just going to shrink this down, not shrink it down, so drop the opacity for the station point. I'll put a dot there so I know it's there. So what I probably want to do first is not just start randomly putting down objects. The first thing that I want to do is most likely, and I say most likely because you get around this, if you kind of plan ahead and do a couple of sketches, but let's say we want to do this in one go. Then the first thing that I'll do is, okay, well, I need to establish the room itself, that is the environment that I'm working with. And so the easiest way for me to establish the room is simply just go, okay, well, let me establish, let's say, a floor. And so if I establish this as my floor, I just realized that's quite off, so let's kind of redo this, because I want to make sure that this is as clean as a sort of example as I can get. So let's say here's the floor, and so that tells me immediately that whatever objects or whatever things I'm trying to mirror, it's got to sit inside this. Now you can make it larger, you can make it smaller, it's really up to you. I've just done this as a quick example. And if that's my ground plane, that's the floor that I'm dealing with, then the moment I pull a vertical line up, I'm starting to create the walls on either end, right? And so we could now say that, okay, based off the environment that I have, this is my mirror room. All right, so I've got my two walls along with my ground plane on my floor. Now let's actually quickly color code this, right? So why don't we say the wall over here, let's make this red. We'll make the other one over here blue. I think we can make this a little bit cleaner. And finally down here, I should have just used the polygon lasso tool to begin with. And we'll make this one yellow, so we use our primary colors, right? Let's drop the opacity down so we can see. So we know that yellow is our ground plane, red is our right plane, and then blue is our left plane, right? So these are all mirrored surfaces. So let's start off with, one of the questions that came up, one of the bigger questions that came up with our work or with homework was, one of them was, hey, how do I mirror the letter N, right? That was one of the things that I think someone had a problem with about how to do N. So let's keep things a little bit simple though. So let's start off with this. Why don't we just place a box first? Right. So I'm going to say that here is my initial box. It's kind of, I have to admit, like doing this tradition is a lot easier because I can see the entirety of my page. I can have a ruler out. You can see how doing, working digitally, it's a bit annoying because this computer's really only just going to show you what the screen is capable of showing. So I've gone ahead and I've created a box like so. And let's treat it as just as a box for now, right? And so we're going to mirror this. Just going to fatten the line weight. So let's mirror this first and foremost. And let's mirror this along the red plane first, right? So the right-hand side of the wall. There's that gap over here. Right, and we talked about how to mirror across gaps, but let's still go through that entire process. I'm just going to make this a little bit smaller. Now, as I've created this, I'm keeping a lot of these lines because they might be useful. I know that the object can't exceed these lines that I've drawn. So let's say I want to mirror this across. Let's find where this goes all the way through the other side first. So to do anything, we firstly need to find the center, so that's why I'm bisecting my object to find that center. And so now what I'm going to do is this line that runs against the wall, I'm going to go from corner across the middle here. Oh, almost, there we go. That brings me to an intersection point there, so I can pull that up. And that gives me this section all the way over here, right? Now I need to find this. Well, same thing. Corner here through the center. And that gives me a point there. That brings up along this side. Now, because I already have these lines to create the bottom, that means that on the other side, I already have this section done for me. I don't have to worry about it because it's a continuation. And because if I have this or this part already as well, all I need is just to pull these lines back. And that will help close off the object. And so if I follow that line back, there's that corner, it comes up, right, sitting somewhere like this. And we've got a bit of a bad tangent here. There's not much we can do about it unless we want to go in and change our drawing. And so this is where doing some sketches, to begin with might be useful. So that gives me two objects here that are mirrored. Well, what I can then do is go, okay, well, let's mirror this down below, right? So the same thing, I've got my center there. So cut a line from this corner across the middle. Oh, almost, there we go. Ah, so close. Oh, it's getting worse and worse. There we go. Can extend these lines down. And all I need to do now is to intersect from here across that. And if I have this part, then I can just bring these lines down as well. I can bring this line down, I can move it across. All right, so all of this should be pretty straightforward, but what I'm trying to demonstrate here is how we can be a little bit more efficient with what we actually measure and what we don't have to measure. Right, so again, if I extend that down, because we're not doing any gaps for the bottom projection, right? Because it's sitting on a ground plane. I suppose if it's a mirrored surface, it might have just physically a little bit of a gap, but let's pretend it's not there. So that gives me a mirror going towards the screen left, and it gives me a mirror going towards vertically down as well. So what we need to figure out now is a mirror back along the blue plane. So if I know that this original object here, this is my original object, the one up here, I've got to mirror this back this way. But I also need to understand that from here to here, there is a gap. That's the span that needs to get copied over here, right? So for the sake of this particular example, I'm actually going to, I kept this on the same layer. I'm actually going to erase some of this so that it's a little easier for us to follow, just from a visual point of view. And just like before, let's find the center. So here's the center, just shy of this line here. Let's pull that back. And we know that this is the line that we're trying to mirror across. So I'm trying to transplant this line on the other side. So all the way across. And then this is going to cut back this way. This is going to cut back this way as well. So intersection, corresponding end is all the way back here. And now we can find this. So let's use this one here. So we're using different angles. So crosses there, bang. So now I have this transposed over here. The moment I have this, right, all I need to do, right, is just to continue or keep some of these lines running back. And I've actually already figured out all the other mirrors. Now, why is it that I can say that we've actually figured everything out? Well, it's because the moment I have this distance done, I know that if I follow this through, that comes down. If I close that off, right, so this gives me the mirror of that initial object going on the blue plane. If I can establish this one here, let's kind of finish this off first before I continue. All right, so if I just continue this line through, it'll cut through the corners as it's meant to. All I need to do at this point is pull this line down to meet this one here, right? If this continued through as well, that way, same thing, right? This will cut back this way, right? This goes down all the way through, same thing over here. So the moment that I have this, I can extend it down. And because I have these guys running back already, right? I've got these points already, I can simply just expand them going up. Oh, got a little bit of a bad tangent running through here. But that effectively gives me the rest of my mirror. So it's just being a little bit smart with what you have. So you don't have to necessarily calculate everything. Sometimes you just have to calculate half of it. And through that process of just calculating half of everything, you've actually established the rest of what you need. You don't have to do it again. So now I have the original, I'll call this 1, right? We did this one, so 2, then 3, then let's say 4 is back here, and the rest of these are reflections of whatever it is that we have. So now let's talk about, okay, well, what if I want to reflect the letter N, right? So I have this base that I can use for the letter N. All I need to do is, okay, well, let's cut into this. So if I cut, let's say, something like this down, right, and let's follow this back. So it gives me the draw through. So if I decide to cut this, which is kind of the first part of an N that we're cutting into or that we're creating, you can see that divot coming in, and I want to mirror that across. Well, to find this apex, let's kind of erase some of this in the middle so that we don't have any double lines as far as example goes. I can just take this and I can pull a line back to my vanishing point. And that immediately tells me, okay, well, this point here is going to land somewhere there. All I need to do at this point is to find this line on the other side. So where do we have our middle? We had our middle over our middle, because we got to remember about the gap. The middle was there. So we go from this corner through that middle, and it gives me a point there. So that gives me the line that's here. And what I can do for this is I can say, okay, well, why don't I draw a line down here and go, let's go from here through the middle again. And it gives me a pathway that goes up there. What I'm really after is this part. And so now I can link these together. And if I have that linkage here, again, just like what we did for our primary, I can pull a line back, and that gives me the corresponding points on the other side. I can also take this and move that back, or I could even run this through here in this direction, and I can achieve the same thing. And so that gives me the corresponding notch on the other side. Now if I have this, projecting this gap back, it's pretty easy because I just have to follow these lines first, right? And it gives me an intersection point about there. This one, if I follow back this line, gives me an intersection point there. And so if that goes down vertical until it hits this, and this comes in at an angle, right, we're going to do the same thing for the other side. And bang, now we have this projected back. here as well. And since we've done the projection going this way into the red plane, we've gone projection going to the blue plane, let's talk about the projection going down vertically into the yellow plane. So same exact process. Now remember, we're mirroring things, so this is going to end up somewhere down here. Now we already have these vertical lines that we can pull down because it's a 2-point perspective drawing. So we know that the points, the notch is going to be in between this. But what we don't know is that length, right? Well, what's the angle? Does it go down? Does it move over here? Does it move over there? That we're not sure. But what we can do is, we know again that's the center. We could draw a lateral line along where the notch is here, right, where the apex is, and go, okay, well, what if I need to find out where this distance is down here. So I go this corner, right, because it's that line coming from the VP across this bottom, I guess the inverted apex over here. So from this corner, it's going to go across the middle. And it gives me a point sitting there. That's that intersection. So if I draw a line from horizon line, vanishing point, sorry, over to intersect that point that I have, right? If I follow this down, it gives me a point right there. And therefore, that's that notch cut down. And you can repeat that same process of pulling back to the vanishing point on the other side. And that gives me, oh, that one didn't show up for some reason. It gives me a corresponding point on the other side. This gives me something, that was a bit faint, but yes, it gives me something like this. And there is that notch taken out from the bottom. Of course, if I follow the same lines across, right, I can find out where that notch is on this side as well. Or alternatively, I could pull down from these guys over here and would find that same position. So this is how we would, or this is how I'd go through and establish both the room, right, the ground plane, the two walls, and then how I'd begin that process of creating those letters. Now, I did it in a particular way where I started off with these blocks, right? And then after I established where the mirror of these blocks are, I then went through and then cut into it to create the shapes. Now that's one way of doing it. You don't necessarily have to follow that path. You could create the letters to begin with and then go through and cut into it. Create the letters and then just kind of draw it exactly how it is, or you could go through and cut it in. I find this a little bit easier. Why? Because it's very procedural. It means I only have to worry about one thing at a time, and each one is very, very straightforward, is very, very simple, right? That way it just means that I don't have to deal with too many things at once. It is, however, going to take a little bit longer as a result of that. And that length of time, right, while it takes longer and it might be, you might see it as a little bit detrimental, it does mean that your job or the process of working this out is a little bit easier, right? Because you only have to do a small thing at a time. But hopefully this shows not only the walkthrough of establishing the planes, not only the process of how we can think about creating these mirrors, but it also shows, okay, how we actually apply this within the context of a station point. And as I said, we don't necessarily need to have the station point on the page, right? We don't necessarily need to have the station point there at all. But if we were, this is how, everything kind of comes together. So these were the big questions that, as I kind of skimmed through everybody's homework, these were kind of the more elaborate questions that needed, I think, a little bit more clarity. So I'm going to, I'll post this up and then you guys can go through this in more detail. But I really encourage, well, not encourage, I'm going to stress to everybody, when you're doing the homework, all right, pen and paper, be very clean. Be prepared to do multiple versions of this in the way that you might have to do a first pass, second pass, third pass, etc. to clean things up, right? you want this drawing to be as clean, as precise as you can get it, right? So you don't want any mistakes. You don't want to bump the ruler and then have an error line, etc. You want to be really, really precise with this homework. And again, it's because this homework is about honing both your patience, right, and your tolerance for detail, or tolerances for precision, meaning that we want to really get that tolerance down to as narrow or as small as possible, so that you pick on these things. Because you might think, well, a little nudge here and there, it's not going to make a big deal, and that's certainly very true. But the more it happens, they will compound, right? And it will just get worse and worse as it goes on. So one object, two objects might be fine, but as you get to 3, 4, 5, that mistake will compound more and more. All right. So this is just the sort of the bigger elements of feedback I really wanted to address. Now, what I'd like everybody to do is go back, review your homework, and see if you need to make any corrections, if you need to make any second attempts to this.